Hi and Assalamualaikum. We are from Group 6 at S1205M and we're going to present about scanning electron microscope. This group have 3 members, which is Nurul Aziemah as presenter 1, Nur Fatihah as a presenter 2, and Nuratiqah Asyiqin as presenter 3. So let's get started.
Hi, my name is Nurul Aziemah Binti Mohamad Ilyas Sahuri. I'm going to explain about what is scanning electron microscope and types of scanning electron microscope. First, what is scanning electron microscope? It is an instrument that scans a focused electron beam over a surface to create an image which is colorless and its resolution of 1.0 nanometer. The electrons in the beam interact with the sample, producing various signals. And from the signals, we can obtain information about the surface topography and composition. Scanning electron microscope developed when the wavelength become the limiting factor in light microscope. This is because electrons have shorter wavelength, which enabling better resolution of the image. The images will have higher magnification and depth of field. What is mean of depth of field is we can see the details of the microorganism. For example, maybe there's a fur on the side, or maybe holes, little holes. Okay. There are few general categories of scanning electron microscope based on their capabilities and form factor. Okay, this is a few examples from scanning electron microscope. We can see it's very detailed over here, and this is comparison between light microscope and scanning electron microscope. We can see it's more detailed than over here. Okay, next we have types of SEM, which is scanning electron microscope. First, we have full sizes SEM. It is a traditional model, which means one of the oldest, one of the the starter, which also known as flow model SEM. It provides max capabilities and flexibility. It also covers wide variety of experiments, but it is very widely in price and performance, which the price can change and performance also can change. And full sizes SEM is powered by tungsten emitter, and they can create good quality images at medium magnification. They also have high quality elemental analysis. Okay, this is the full size SEM. We can see it's very large, and this is the component. Okay. Next, we have desktop scanning electron microscope. It is one of the most recent revolutions in electron microscopy. It is small size and it can fit into any lab easily. It is also great for multi-user lab, as not everyone is an SEM expert, or maybe not everyone is familiar with SEM. And this is because they prioritize ease of use while maintaining plenty of power of standard SEM. Phantom TM desktop SEM is one of the example which they're using a Phantom system. They provide excellent quality images and fast elemental analysis for novice expert SEM users alike. Okay. The majority of SEM work can be accomplished with Phantom system. Okay, this is the images of desktop SEM. It is connected with the PC, so the result will come up over here. We put the sample here and the result will come up here. Okay, the last one is automated SEM. It is this automated SEM use a recipe because some standardized analysis can be automated with this special SEM. It is common for particle analysis or quality control applications where statistically significant data is paramount. Why it is so special? This is because they feature a powerful software that can control many aspects of systems operation. They run according to recipes that suits the application, the experiments, and it is also editable. Okay, this is the images of SEM. It is also to automated SEM. It is also connected to the PC, and the SEM much larger than the desktop SEM. And this is the analysis from the automated SEM.
Hi, I'm Fatihah and I will talk about how SEM works and the interaction between electron and sample. So, how SEM works? First, electron beam is emitted from electron gun that usually fit with filament tungsten cathode because it has a high melting point and lowest vapor pressure, and the cost also inexpensive. The electron beam will accelerated by voltage to pass through a series of lenses. After electron emitted, it will passes through an anode because electron, which is negative charge, attracted to the positive charge of anode. After that, a diffracted electron beam form parallel to the incident of the specimen. The use of magnetic lens is to focus the electron beam to specimen of spot about 0.4 nanometer to 5 nanometer in diameter. Magnetic lenses usually consist of two, which is condenser lens and objective lens. The reason of using magnetic lens is because electrons have charge that got influenced by magnetic field. The electron beam then passing through scanning coil, or we usually use deflector plate because scanning coil help to control the position of electron beam and make sure the electron beam scanning the sample in a raster way. So both detector, which is secondary electron detector and backscattered electron detector, are more sensitive toward the electron rather than visible light. Vacuum pump is necessary to prevent the gas molecule that scattered from the molecule disturb the electron beam to focus on the sample. It has three levels of operating, which is high, low, and environmental that depends on the design of the microscope. The specimen can be either flat or tilt surface, so that the spread out of the secondary electron on the flat surface is mostly contained by the sample, but tilt surface is preferable because more electron emitted to the detector and the plumb of the secondary electron is partially exposed. Next is the interaction between the sample and electron. The result of interaction can produce a few types of signals such as secondary electron SE, backscatter electron BSE, characteristic X-ray, light such as cathodoluminescence, CL, specimen current, and transmitted electron, but famously used in analysis is backscattered electron, secondary electron, and characteristic X-ray. First is secondary electron SE. Secondary electron SE is a result of inelastic interaction between electron beam and the sample. It is emitted from the surface of sample with depth in 100 nanometer because it have low energy, which is less than 50 electron volt, but mostly it can produce high resolution image in secondary electron imaging. It also provides more details about sample surface, thus the image contrast mainly reflect the surface topography of the sample, so that it more preferable in studying the surface of an element. The SE detector is placed at the side of the electron chamber of SEM to increase the accuracy of secondary electron detector. Backscatter electron BSE. BSE is most preferable analysis in SEM, and it's often used along with spectra from characteristic X-ray. It is a result of elastic interaction between electron beam and the sample because it reflected from the sample in depth 500 micrometer. It is most preferable because BSE signals show high sensitivity to the atomic number of the sample. Thus, the higher the atomic number, the brighter the materials appear on the result. So the image contrasts mostly provide information about the composition of the different elements in the sample. Third is characteristic X-ray. Characteristic X-ray is when electron beam knock out the inner shell electron from its shell, so the atom of the sample is not in a stable state. Thus, the outer shell of the electron, which is in high energy state, fill in the shell, that which cause the loss of energy happen. So this process will stabilize the atom. Hence, the characteristic of the X-ray are emitted. So characteristic X-ray are used usually to examine the composition of a sample and measure the abundance of the element in the sample.
Hi, for the last part of this presentation is about the sample preparation and application of SEM. The specimen must have at least an electrically conductive surface to be able to be imaged by SEM and need to be electrically grounded to prevent the accumulation of electrostatic charge at the surface. All specimens also need to be in an appropriate size to be fit in the specimen chamber and generally mounted rigidly on a specimen tub, which is also the specimen holder. For non-conductive specimen, it is coated with an ultra-thin coating of electrically conducting material by using low vacuum sputter coating or high vacuum evaporation. Example of conductive materials are gold or palladium alloy, platinum, osmium, iridium, tungsten, chromium, and also graphite. Why non-conductive materials can be used in SEM? Because they tend to charge when scanned by electron beam, especially in secondary electron, that can cause scanning faults and other image artifacts. Here is the application of SEM. First, for material science, SEM is used for research, quality control, and failure analysis. In modern material science, it is used for investigation into nanotubes, nanofiber, high temperature superconductors, mesoporous architecture, and alloy strength. SEM has been used from aerospace and chemistry to electronics and energy usage. For forensic investigation, criminal and other forensic investigation utilize SEM to uncover evidence or gain further forensic insight that include analysis of gunshot residue, jewelry examination, bullet marking comparison, handwriting and print analysis, examination of banknote and authenticity, pin particle and fiber analysis, filament bulb analysis in traffic accidents. For biological science, SEM can be used on anything from insects and animal tissue to bacteria and viruses. The uses of SEM include measuring the effect of climate change of species, identifying new bacteria and virulent strains, vaccination testing, uncovering new species and work within the field of genetics. For arts is to can create digital artworks, create a range of diverse landscape and image subjects. Soil and rock sampling. The geological sampling use SEM to determine the weathering processes and morphology of the sample. Backscatter electron imaging can be used to identify the compositional difference, while the microanalysis can provide the composition of elements. The use of SEM in soil and rock sampling include identification of tools and early human artifacts, soil quality measurement for farming and algae culture, dating historic ruins, and forensic evidence in soil quality, toxins, and others. The nanowires for gas sensing, SEM help in characterize the nanowires and understanding the gas sensing behavior. Semiconductor inspection use SEM that has accurate topographical information for a reliable performance of the semiconductors. It also used as a quality control tools for water manufacturing processes. For microchip assembly, to gain insight into the effectiveness of new production and fabrication methods, to design low-cost, low-power chipset for non-traditional computer and network device. In medical science, SEM are used to compare blood and tissue samples to determine the cause of illness and also measure the effect of treatments on patients, also to contribute in designing of new treatments. Common uses of SEM include identifying disease and viruses, testing new vaccination and medicines, comparing tissue sample between patients in a control and test group, lastly testing samples over the lifespan of a patient. All of these applications are done thanks to SEM. High-resolution three-dimensional images were produced by SEM that offers speedy and accurate measurement. That's all from us. Thank you.